Section 1 is all about roots and radical expressions. This screen can be a little confusing, so I want to give you some concrete examples of each of these. N is the actual index that you're taking. So if n is odd, that means you're taking an odd root, like a cubed root or a fifth root, and you only get one actual answer. So the cubed root of 8 is 2, or the cubed root of negative 8 is negative 2. That's completely different than when your index is even. Odd indices are really easy to work with and not very picky. It's the even ones that are a problem. The first one talks about if n is even and your number underneath is positive. In words, you get two roots for that. Something like the square root of 4 is plus or minus 2, because positive 2 times positive 2 is 4, and negative 2 times negative 2 is 4. The one that's positive, the positive 2, is called the principal root, it's the primary root. Its opposite is the negative root. That would be negative 2. The most important one to remember is this one right here. If n is even and b is negative. So something like the square root of negative 16. In chapter 4, we learned that that was imaginary. But here, because they talk about real roots, this is a no solution. Anytime that this number right here is even, that's understood to be a 2, and this is a negative, you end up with a no solution. So take a look at the first example. In words, anytime it's an even root, you need a plus or minus. You're going to notice that the first three are all odd roots, so no plus or minuses are necessary. In number 1, the real cube roots of negative 1,000. They're asking you what number times itself 3 times gives you negative 1,000, and the answer is negative 10, because negative 10 times negative 10 times negative 10 is negative 1,000. It's okay to be negative. This number right here is okay to be negative as long as you're doing odd roots. Number 2, what are the real cube roots of 0.008? This one happens to be 0.2 because 0.2 times 0.2 times 0.2 is 0.008. And number 3, what are the real cube roots of 1 over 27? When it comes to fractions, you can cube root or square root the top and bottom separately. So on the top, the cube root of 1 is 1, and on the bottom, the cube root of 27 is 3. So the answer is 1/3. In 4, 5, and 6, we're changing gears just a little bit. These are all even roots. And so if this is a positive radicand, we can do plus or minus. In fact, we have to. So number 4, what are the real square roots of 36? End up being plus or minus 6. In number 5, the real square roots of 0.01 are plus or minus 0.1. And in number 6, we're talking fourth roots, not square roots, fourth roots. The fourth root of 16 is 2, and the fourth root of 81 is 3, plus or minus because it was an even root given to you in words. Just a quick look at some vocabulary. The little number written in the upper left-hand corner is called an index. If it is not there, it's understood to be a 2. So that's this number right there. The big number underneath the radical is called the radicand, and then the symbol around it is the radical sign. If you physically see a radical sign within a problem, there is no plus or minus. So if you take a look, all of these have radical signs there. So there's no plus or minus for even roots. Number 1, the cubed root of negative 8 is negative 2, because negative 2 times negative 2 times negative 2 is negative 8. In number 2, the square root of 0.81 is 0.9. No plus or minus because it wasn't given to you in words. For number 3, because this number is even and that's negative, this is a no solution. In this whole entire chapter, you cannot take even roots of negative radicands. In number 4, according to your dear Aunt Sally, you have to pretty up what's underneath first. When you take negative 2 and square it, you get a positive 4, and the square root of 4 is 2. Not plus or minus because it's not given to you in words. Just a reminder in letter C, that answer is no solution because you have an even index and a negative radicand. anytime you take an even root, so a square root or a fourth root or a sixth root, and you end up with a variable in your answer that has an odd exponent, you have to include absolute values in anything that ends odd. So if you look, this 4 is even, and both the 3 and what's understood to be a 1 are odd. So you need to put absolute values around anything that starts even with an index and ends with odd exponents. So just a quick glance at 1 through 4, you don't have to worry about that rule in number 3 because it starts with an odd index. So number 1, take the square root of 25, you get 5. And the square root of x squared is x. Because you started with an even index and ended with an odd exponent, you need absolute values around the x. Number 2, the square root of 36 is 6, and the square root of y to the 6 is y cubed. Because you started with an even index of a 2 and ended with a 3, which is odd, you need absolute values. In number 3, the cubed root of 27 is 3, and the cubed root of x to the 6 is x squared. No worries about absolute values because you started odd. And in number 4, the fourth root of 16 is 2, and the fourth root of y to the 4th is 1, which means you need absolute values because you ended odd. Just a quick reminder, to find the exponents on those variables, you take the exponent you started with and divide by the index. So 6 divided by 2 is the 3 that we get. We're skipping number 5. Number 6, the cubed root of x to the 6th is x squared, and the cubed root of y cubed is y. No absolute values are necessary because you started odd. In number 7, the fourth root of 81 is 3. The fourth root of y to the 8th is y squared, and the fourth root of z to the 12th is z cubed. In this one, you started even, and you ended odd only on the z, so only the z cubed needs absolute values. In number 8, the fourth root of x to the 20th is x to the 5th, and the fourth root of y to the 8th is y squared. You started even and ended odd on the x, so you need absolute values. Absolute values are only needed on B and D here because they are the only two that started even and ended with any odd exponents. Letter A started even, but it ended even, and that's okay. And letter C started odd, so that's never an issue there either.